Hey everybody, welcome back to the Meta Career Questions. Today I have solved tunnel time. Let me tell you about this problem. So we have a track. Let me go to my whiteboard. We have a circular track. So it has positions. Oh my god, need to change it to a pen. So here we have a circular track. It goes in a circle. There's my circle. And there are the track has markings like this. This is really bad. Can I open up? Not that. If I open up this, is it going to be more accurate? I hope so. Is it? Whatever. 4, 5, 6, 7, 8, 9. Let's just say it's 10 because this is the example it's given. So we have a circular track and it's marked, it has some number of meters. So this track has 10 meters. I think it's the value C for the circumference of the track, 10 meters. So on this track, there are tunnels, and the tunnels, they start at a certain, for let's say like 1, and it goes to 3. So the tunnel starts here and ends here, and then we have a tunnel that starts here and ends here, and we're given where these tunnels are. So A is where the tunnel starts. So there are 2 tunnels, so n equals 2. Let me write this. N equals 2, this is the number of tunnels, and then A is the starting point of the tunnels, so 1 and 6, and B is the ending point of the tunnels, so 3 and 7. Then is there another parameter? K. Yeah, right. So here's the objective. Let me write down what the objective is. The objective is we're given a K. So let me draw what the tunnel looks like. So here's tunnel, and then here's tunnel. So this tunnel has size 2. The tunnel has size 1. So let me write down 1, 2. So we're given a K, like for example, K objective. Given K equals 7. What we want to do is, what is K? K is a number of seconds that you spend inside a tunnel. Number of seconds spent inside any tunnel. And so now, given that you're traveling in a circle, so you're traveling in a circle. You know, the first when you go around the circle and you go back to the beginning. So this is quite inconvenient. Can you not do this? Okay. Please hold. Wow, this is annoying. Okay, cool, we're back. So objective, given K equals 7, which K means the number of seconds spent inside a tunnel. So here's what we're gonna do. We're gonna go around the circle. We're gonna spend 2 seconds in this tunnel. Then when we're gonna get here, we're gonna spend another 1 second in the tunnel. Then we're gonna loop back around, and then we're gonna spend another 2 seconds here, and then another 1 second here. So the question is, if we want to spend 7 seconds inside a tunnel, so we go at a rate of 1 meter a second. I should also say that. So we get through a tunnel of size 2 in 2 seconds. So the speed is 1 meter a second. So then given a K, we want to find out where will we be? Where will we be when we have spent K seconds in the tunnel? And more specifically, the answer that we want specifically is how long until we spend 7 seconds in a tunnel. So let's look at the example that I gave above. So we're gonna spend, if we start going here, we're gonna spend 2 seconds in this tunnel. We haven't reached 7 seconds yet, right? Then we're gonna get to here, we're gonna spend 1 second here, and then we're gonna loop back around. We've only spent so far 3 seconds in the tunnel, so we need to keep going. So we're gonna keep doing another 2 seconds here, so that'll bring us up to 5. This will bring us up to 6, and then when we're halfway through this tunnel, this is when we finally hit 7, the third loop around. So then what we want, the answer that we want is 22 for this example. Why 22? Because each loop takes us 10 seconds because the loop has circumference 10, or there's 10 meters in every single loop. And then the place we end up at is 2. So that means that it took us 22 seconds to get to a place where we finally have spent 7 seconds inside tunnels. So the answer is 22 seconds. So the thing about this problem is your way of dealing with these loops has to be pretty efficient. Because n, so C is huge, n is huge, and so yeah, so it just, you have to be very efficient in finding out which tunnel. There can be also so many tunnels. Yeah, there can be like I think that C goes up to 10 to the 12 or something. Yeah, something crazy like that. K also goes up to 10 to the 12. K is the number of seconds. So these numbers are really big, so our answer needs to be really efficient. And if n is up to 500,000, we have an array of possibly 500,000 tunnels, right? That's gigantic. So let's try to look at how to solve the problem. So one thing that clearly stands out, right, is we can, to simplify the operation, so we have this 7 seconds, right? But we can easily find out the number. So here's the first thing that will help you solve this problem. So given that we know the tunnels, how long they are, so what happens if we sum up the length of all the tunnels? Sum up length of all tunnels. So in this case, the length is 3, right? 3, because there's 2 tunnels. So then, so we're looking for spending 7 seconds in a tunnel. However, we know that it takes 3 seconds, that by looping once around, we have spent 3 seconds in a tunnel. So we can take 7 and subtract 3 and subtract 3 again. And now we know that we have to spend at least 2 full revolutions. So we end up with 1K left, 1 second left in the tunnel. But what does this mean? This means that we have to spend, we do have to go through an entire 2 revolutions before we consider the leftover. So this is kind of like a division, and it allows us very quickly to because we need to spend, we need to go in the order, and we need to, in order to get more seconds, we need to pass through all of our tunnels. So if we know that our tunnels are less than, if we know that the sum of all the seconds possible in a circumference is less than what we than our K, right? We can just remove we can consider it like a full circle, right? We can remove that from our calculation of K and then add a circumference later. So a circumference takes 10 seconds, right? So we need both of these 3's to get to a low enough K. So therefore we can just add 20 to our final answer. So that's a very easy to way. So what does this require? That's summing up the length of all the tunnels. This requires taking each of the BA, so BI, right, minus B. Let me check. I'm recording. Am I recording? Yes. Wait, am I recording? Oh, I gotta. Wow. Let me see. I can't believe it does this. Okay. So hopefully I'm recording now. Yeah. So we have to take the AIs and the BIs and subtract them. Yeah, I think this must be a bug. And sum all these up, right? So let me do a summation, a very fancy summation over all I, and it's the length of all my tunnels, right? So now that we've successfully removed a large part of the calculation by just removing these circumferences, right? All we have left is we have some K that is less than all the seconds. So we know that this K is somewhere in the ballpark of, so if it's 1 second, right, then we have to find out which tunnel we stop at, and also we have to find out within a tunnel, if we already found the tunnel which we expect to stop at, where inside the tunnel, because if it's at if it's at this place. So one thing, obviously, so when you just start enter into a tunnel, that doesn't add any time that you spent in the tunnel. Therefore, it doesn't make any sense to, like, it's not possible that this is the place where you end up, because the tunnel time is added after you spent an entire meter inside a tunnel. And so you can't just entering the tunnel doesn't give you any extra tunnel time. So there's no way that's going to get you over to the amount of tunnel time that you want. So the only possible places for where you might end up is this, and this. Hopefully that makes sense. Still recording. Yes, I'm still recording. So basically we want to, now that we've removed a bunch of these circumferences, we have some k that is less than the total number of tunnel time that we need, and we just need to find out which tunnel we end up at, and find out what the endpoint is. So we could, so here was my original strategy for this, was just to loop through all the tunnels, and then so loop through tunnels, get their lengths. So get length of tunnel, and then if k is less than length, so by k I mean this remainder. If the k is less than length of the tunnel, then we, this means we finally found our spot. So this means that, so this will help us give our answer. So if we finally found out that our this is the right tunnel, what I mean by this, like if we have a k, right? So the idea is, okay, let me just say instead what happens if k is greater than length. What does this mean? This means we need to see more tunnels. Need to see more tunnels. So this means we're going to take k and set it to k minus length, and then we're going to go to the next tunnel. Hopefully that makes sense. So now what happens if k is less than length? This means we finally found our tunnel. Finally found the right tunnel. So then we can do some math probably, and then just, you know, something like the beginning of the tunnel. So it's a of I plus k. And this should be this position here. And so then we'll take this answer right here and add it to the circumferences that we used before. So plus 3, or not, so not 3, plus 10, plus 10. So we've gone around twice. And then this is where this started, and then plus k, which is the number of tunnel seconds that we needed to get through for this one tunnel in order to finally hit our goal of 7 tunnel seconds. So that's how we end up with 22. Because in this case, a of I will be 1, and then we'll need 1 more tunnel second. So this will be 1 plus 1, which is equal to 2. That's how we hit 22. Hopefully that makes sense. So a couple problems with this approach that I was seeing. So first of all, probably the biggest problem is that there are possibly 500,000 tunnels, right? And if there are 500,000 tunnels, then this loop is not going to work. It's going to be too slow to loop through every single tunnel and subtract off the k. I hit a probably like out of time, you know, when running the tests. So what is the solution to this instead? The solution is, instead of keeping a list of tunnel lengths, what we're going to keep track of is instead a cumulative list of tunnel lengths. What do I mean by that? So the list of tunnel lengths, so this is what it usually looks like. So we have 2 tunnels. So here are our lengths. And instead, so we're going to cross this out. Instead, we're going to keep a cumulative list of tunnel lengths, which looks like this: 2, 3. So this 3 is just the previous, the sum of all the previous elements. So this 3 is equal to 1 plus the sum of the previous. So it's a cumulative sum. So this element is equal to the 1 plus everything that came behind. What is the point of writing it like this? First of all, when we calculate the length of the tunnels, this will be super easy. I should also mention that the tunnels, let me check that I'm still recording. Yeah. Tunnels are not sorted, so you have to sort them. So that's O log n, but it's fine, doesn't matter. or not O log n, yeah, n log n. Not a problem though. This is good enough for our case. I mean, they pretty much have to be sorted because you will need to go through the tunnels in order, right, to find out which one comes before which tunnel. So that's pretty much unavoidable. I erase this here. So this 3 is the sum of the lengths of all our tunnels. So lengths of tunnels. So this saves us a calculation, which is convenient. But furthermore, so here's the point of this, right? So let's just say our k is equal to 1 in our example. What does this mean? This means that we need to spend 1 more second. So k obviously after subtracting the 3 and the 3, right, to get a remainder after our revolutions, which is our shorthand of, instead of having to keep running this process over and over again, we know that if the number of seconds that we need is greater than the length of all the tunnels, then we can just skip an entire revolution and add at the end, right? That was the point of the skipping. So 2, 3, length of tunnels, saves calculation, right? So if our k is 1, here's what I'm gonna do. I'm gonna do a binary search. So binary search is O log n. It's a very quick operation. We're gonna do this in the cumulative list. So what does it tell us? So we're gonna look for this k equals 1 inside this binary search, and this will tell us, so where is the insertion spot? The insertion spot is I equals 0. So let's try instead to look for k equals 2. The insertion spot is still 0. If we look for k equals 3, this is when it changes, the I equals 1. So what does this mean? This means that, like, what is the point of this? The point of this is that, so we need to travel some number of seconds, right? And we want to find out which tunnel we need to travel this number of seconds. So this, if we wanted to travel, if our final answer is k equals 1 or k equals 2, that means we want to end up on the first tunnel, right? So when we binary search and find out that the place, so basically we're trying to, what the binary search does, right, is it finds the place where I need to, in order, the element that I find is smaller than, yeah, so basically I'm trying to find the correct index to insert to the left of. So if for k equals 1, I found this index, because if I try to insert and keep the sorted order, that's what binary search is for, then I will have to insert, I will have to put, insert it before the 2. And if it's the same, I also get the 2, so I also have to insert before the 2. Like if the k equals 2 and 2, then I still get the 2, not the 3. So what is the point of this? So if we need 2 seconds, right, our first tunnel is enough to cover this requirement of 2 seconds, which is why we get this so like, I don't know how to say it, like I guess the best way to say this is at position I is the number of seconds, position I is the number of tunnel seconds that is possible that we can get, we're capable of getting it. We can get number of tunnel seconds that we can get if we travel through all, let's say, I minus 1 tunnels before this and end up somewhere on tunnel I. Hopefully that makes sense, because we just summed up the lengths, right? So so if we look at this position here, which is I equals 1, we summed up the lengths of the tunnel 1 and tunnel 2, and this matches the possible number of tunnel seconds that we can get if we went through all of the previous tunnels and end up on this one. I think that makes sense. So we do this binary search and we find the right place to insert. And so then what we do, so this is a really fast operation, right? We don't need to do this 500,000 loop. We can just do this O log n, so O log 500,000, which is much faster. So we can find the right place. Then we already know what this cumulative sum is. So we take our, what we do is let's just say, let's call this array cum. I'm gonna rename that actually, cumulative. So there's our array cumulative and cumulative of I minus 1, sorry. So this will be the number of seconds that we got for free by traveling already to this ith tunnel. So we take that. Right, I forgot what the exact expression is. Let me check in my solution. So it's this A, which is where the tunnel starts, K minus previous tunnels, right? Because the K, so the previous tunnels already covered part of the solution, and then we want to find out how much more of the current tunnel do we need. So we take K, we subtract from it the cumulative tunnels, and then we add to it the starting position of this tunnel, AI. And then we take this and we add it to our C times the number of revolutions. So that's our answer. The other thing, I was getting the wrong answer on like nine test cases. And I finally figured out what the problem is. The problem is with our current algorithm, let's just say our K is, for this example, let's say our K equals 3. So what does this mean? This means, so the number of seconds in our revolution is also 3. So, I mean, what should we do according to the problem statement? So we should go through these 2 seconds, then we should go through this 1 second, and then we should stop here. Why? Because we've already hit our number of tunnel seconds. Right here, exactly right here. We've already hit it. Number of tunnel seconds hit. So we should return 7. It took us 7 seconds to hit the 3 tunnel seconds, right? However, my answer currently does not do this, right? So I sum up the number of tunnel seconds, which is equal to 3, right? Then I, since 3 is bigger than or equal to 3, we do that division, right? To see if if 3 is bigger than 3, then we subtract the 3 and we end up with a K which is less than 3, right? To save time. However, and then what we end up returning here is 10 seconds, which is the wrong answer, because all you need to do is get to this last tunnel. You don't need to get to 0, right? So that's definitely the wrong answer. So the answer is then you just add an extra if statement. So if, after doing this division and finding the remainder when you divide by the number of length of the tunnels, so if K is equal to 0, then what you're going to do is you're going to treat it, you're going to say number of revolutions minus equal to 1, like as if you haven't finished the last revolution. And then you're going to set K equal to the length of the tunnel. And you will still have to do this algorithm down here, this one. Search through, do that insertion, the binary search, to find out where exactly is the last spot. I mean, maybe I could have made it faster, just by looking at the very last tunnel and seeing its end spot, but this is good enough. We set this K equal to the length of the sum length of all the tunnels. So knowing that pretty much solves the problem. Yeah, it seems straightforward at first, but it has some complexity, especially with the with the conditions given, especially also with this bug that I did not consider ahead of time. This was important. So that's it. Thank you very much for watching the video. I'll see you next time.